Alright, so this is the lesson for day 160. We're a day behind, so but the objective for today, we're going to talk about those relative frequency tables, but we're going to talk about it in terms of percentages. So if there are like 30 students in this class, and all 30 of them are here, how many percent of students are here? How many percent? 100. Good. Does that make sense so far? So it's 100%. So think about that. Think about the total number of students. When you have that, then you could calculate anything by dividing it. Okay? So the steps we'll talk about as we go. Here are some vocabulary terms. Relative frequency is the frequency of category divided by total frequency. So like, let's say how many, raise your hand if you're a girl, and then 15 of you raise your hand, and there's a total of 30 students. What's the percentage of girls in here?
50%.
50%. Does that make sense so far? Okay, good. Joint relative frequency is found by dividing a frequency that is not in the total row or the total column by the grand total. It tells what portion of the total has both the two specified characteristics. Okay, so we talk about two characteristics. So let's say you're a girl that is a 9th grader. Raise your hand if you're a girl that's a 9th grader. 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 30. Okay, so that I could get a percentage for that. 8 out of 30. Does that make sense? Marginal relative frequency is found by dividing a row total or a column by the grand total. It tells what portion of the total has been specified characteristics. So it's like, again, how many girls in the class, 3%. And then conditional relative frequency describes what portion of a group is with a given characteristic, also has another characteristic. Okay, so and a conditional relative frequency is found by dividing a frequency that is not in the total row or the total column by, or that is not in the total row or total column by the total for that row or column. So, for example, let me explain this to you. There are 15 girls in here, okay? And let's just say that I don't care about the 30 students. I want to know what is the percentage of girls that have a athletic class during the day out of the 15. Raise your hand if you are one of those girls that has an athletic class, like you have PE or swim, or you have like a sport. Okay, you got 1, 2, 3, 4, 5. Only 5 of you. 5 out of 15 is how many percent?
Didn't you say PE?
Yeah, so let's just say there's 5 girls that have an athletic class during the day. I only care about girls. The question is, what's the percentage or what's the frequency of girls, or what's the frequency of students that have a PE class given that they are a girl? Again, how many total girls are in here? We are given 15 girls. How many of the girls had a PE or athletic class? 5. So 5 out of 15 or 33%, right? Or 1/3. Does that make sense so far? So it's not out of 30, it's only out of 15. Okay? Cool. Okay, so here we go. Now, this is similar to last week. I'm going to show you how to calculate the percentages using a calculator, okay? So Millie, here we go. Millie performed a survey of students in the lunch line and reported which type of fruit each student selected along with the gender of each student. So let's just pretend there's a girl named Millie. She's hanging out at the lunch line. People are coming past her, and she's all like, hey, you're getting lunch. If you were to get a fruit, what would you get? And the person says apple, and then she realizes, oh, is that a boy or girl? And she checks off. So she counts up all the fruits and what kind of person they were, a boy or girl. Okay, what gender they are. Okay, so she figured out, hey, there's 16 girls that like apples or prefer apples. There's 25 boys that prefer apples. There's 10 girls that prefer bananas. 13 girls that prefer, or 13 boys that prefer bananas, and so forth, right? And she adds them all up, and then how many total students did she end up?
92.
That's right, 92 students that she ended up surveying, okay? So if she surveyed 92 out of 92 students, how many percent of students did she survey?
100%.
100%. Does that make sense? Okay, so how many total students is 100%?
92.
92, okay? That's super important you realize that, okay? So the way we figure out percentages, for example, on this example they already started giving us a percentage like 17.4. How did they figure that out? Well, they used their calculator. So the calculator, what they did is they realized, hey, look, there are 16 girls that like apples, okay? So if I wanted to figure out what this yellow part is right here, I would look at this mark right here, 16 out of the total of 92, and I would go to my calculator and I'd clear out my memory. And I go 16 divided by 92, and I get the answer of 0.1739. And then I want to make that a decimal point, so then I move the decimal place 2 points to the left. Or, I'm sorry, 2 points to the right, and I get 17.4. Does that make sense? Okay, so I like you to practice. We're going to get these answers right now. Let's all take out your calculator. Calculator's out. Calculator's out. Okay, so on this one, let's do the same one again as the calculator. So let's clear out your calculators and let's do the number 16. So we have the number 16 here, and we want to figure out what's the total percentage 16 is out of the total amount of students. So let's do 16 divided by 92. One more time. We're all doing this to practice. Everyone is practicing because I don't need to practice as a teacher. I already know how to do this. 16 divided by 92 is 17 point what? Or 0.17 what? Okay, let's move the decimal 2 places to the right. What do you get? Good, 17.39, or we write 17.4 here. Okay, let's keep going. What's the next one? There are 25 girls that like apples. 25 boys that like apples out of the 92. So let's put that into our calculator. What's 25 divided by 92? .2717. Move the decimal 2 places to the right. What's the percentage? Okay, why do we write 27.2 up here then? Good. We're rounding to the nearest which spot? Tenths. Okay, good. Next one. What's 41 divided by 92 on your calculators? 41 divided by 92. Okay, good. And then let's round it to the nearest tenths place for our percentage. Good. Okay, 44.6. Did you all see how that worked? Let's keep going here. Now we're going to start filling it in. What's 10? Let's go to this next one. We have 10 girls that like bananas, okay? What total percentage of what's the total percentage of students that are girls that like bananas, okay? Okay, so it's 10.9. Good. Next one. What's the total percentage of students that are boys that like bananas? 14.1. Okay, so the next one. What about 23? There are 23 total students that like bananas. So what's the percentage of students that like bananas?
25%.
Okay, 25. Good. Now, check this out. I'm going to put 25 here. Remember the other day when we added these up? We added these up. Like I added this one plus this one. What are these two when we add them up? What are they equal to? 25. Do you notice that? Good. So that's a good way to check your work. Because if you're not adding them up correctly, that means you're not doing it correctly. Does that make sense? Keep going. How many girls, or what's the percentage of girls that like oranges now?
15.2.
Good, 15.2. Okay, next one. What's the of all the students, what percentage of them are boys that like oranges?
15.2.
Okay, good. And what's the total percentage here?
30.4.
Good. So how'd you do that so quickly? Add them up. Okay? Does this make sense? Keep going. What's the total, what's the percentage of girls that what's the percentage of students that are girls now? We have 30 girls out of 92. What is that? 43.5. And then how many students are boys then? What's the percentage? Good, okay? Good. So now that we see this, we could easily look at the answers when we want to figure out, okay, what's the percentage of girls that selected it, or percentage of students that selected an apple specifically? Well, there's 44.6% of students, right? Or how many selected a banana, or how many selected an orange, right? And then we also see, Millie's, the percentage of boys and girls, right? So did Millie get more boys or more girls?
More boys.
More boys, right? You see how easy it is to look at those numbers, right? Is it a lot more boys or just like a few more boys?
A few.
A few, right? She didn't really go a huge percentage more of boys, right? Right? Okay, so is this a hard concept? No. Okay, good. So let's have you do this next one, okay? So, I'll read this out loud. Use the two-way table of data from another student survey to answer the following question. So, it looks like the student is looking at two things. She asked, do you like weightlifting? Yes or no? And then she also asked, do you like aerobic exercise? Meaning like cardio, like running, swimming, or... Okay? Eyes up here. Eyes up here. So she collected the data and she asked how many total students in this example. How many total students were
40.
interviewed? 40. So 100% of students is how many students in this example? 40. Does that make sense? Okay, cool. So with your group, I'd like you to fill in the percentages for each of these boxes, okay? You might want to assign someone to be the calculator person, someone to be the writer, okay? And someone to check the work with another calculator, okay? Go. You should have taken the time to work on these. Here we go. Here are the answers for percentages. So we can now see percentages, right? And where the most people are in. So from here, I could see, hey, just focusing on all of my percentages, I noticed that more people, or the most people, don't like aerobic exercise, you see, but they like weightlifting. So there's a lot of people that like lifting weights, but they do not like aerobic exercise. You see that? Most people are there, right? And you can see that even here. There's 14 people here, 7, 12, and 7 around it. Okay? Now, let's just say I wanted to focus on, there's one more concept I want to show you. Damien and Eli, can you please focus? Thank you. Okay, so let's just say I wanted to focus on people that were not into aerobic exercise. Okay, not into aerobic exercise. All eyes up here. So how many total people are not into aerobic exercise? No, how many people? What's the percent? Well, how many people? 21, right? Okay. I want to focus just on those people. Of all the people that do not like aerobic exercise, how many of them how many of them like weightlifting? 14. So what's the percentage? Is it going to be 14 out of 40, or am I going to only talk about 14 out of 21?
14 out of 21.
21, right? So listen to my question. Ready? What's the marginal frequency, or what's the frequency of people who like weightlifting given that they don't like aerobic exercise? What's given? That they what?
Like weightlifting.
No, given that they don't like. So how many people don't like aerobic exercise? 21, right? How many of those people, given those people, how many people like weightlifting? 14. So what is that percentage? Now we have to do a new percentage, right? What is that? Good, 66.7%, right? Or 2/3, right? Does that make sense? So did we use the 100% like the 40 students on that example? No, so sometimes you have to be real careful what the question is asking. Sometimes it's saying, hey, I want you just to focus on people who don't like aerobic exercise. Okay? Or it could be the other way around. You could say, given people like weightlifting, what's the percentage of them that they also like aerobic exercise? So how many total people like weightlifting? How many total people like weightlifting? Got 7. How many total people like weightlifting? 21. Good.
Oh, what's
Given that we know there's 21 people who like lifting weights, how many of them also like aerobic exercise? What's the percentage? So how many people also like aerobic exercise?
47.
7. What's 7 out of 21? 33.3 or 1/3. Okay? So you have to focus your mind sometimes on a certain category, okay? Does that make sense? Okay, cool. And that's it for now. So that concludes the lesson.